Good afternoon. Today we're going to discuss about the conversion from exponential to logarithmic functions and vice versa. We'll be comparing features of these two functions using various representations, using appropriate tools, and using critical thinking. Let's go first to our applications in here. So exponential functions are used to measure growth, interest, and decay. For examples, in terms of human population, gossips, virus and bacteria, computer technology, chain reactions, nuclear chain reactions, and compound interest. This can also be like an exponential decay in terms of carbon 14 dating, half life, or even Newton's law of cooling. In terms of the use of logarithms, it is used in a Richter scale to determine the magnitude of earthquakes. It is also used in the measuring the acidity of certain solutions. It also is measured in terms of decibels in sound intensity measurement, and also in terms of expressing larger values. Now let's go to our details regarding the exponential and logarithmic conversions. Here is our graphic organizer for exponentials and logarithms. So exponential is always this one in yellow here, which is always either increasing or decreasing. It always has a horizontal asymptote, while a logarithm always has a vertical asymptote like that one. So they are both curves, but we can see later that they are in fact inverse functions of each other, which means that whatever the dependent variable is for the exponentials, that will be the independent variable in the exponential will be the dependent variable in the logarithm, and vice versa. So in here we can read this one as a to the b equals c, where a is the base and b is the exponent. In terms of logarithm, we can write it as follows. Logarithm base a of c is equal to b. So that's how it was read. So again, as we may see, the base on our exponential will be the base number on our logarithm. The exponent in our exponential will be the answer to our logarithm, while the answer to our exponential will be the number here, c, for our logarithm. We'll have some examples in here. For example, 2 cubed equals 8. In terms of logarithm, we can write it as follows. Log base 2 of 8 is equal to 3. So the 2 base number on the exponential becomes the subscript, which is the base number for our logarithm. The answer for our logarithm 3 is in fact the exponent in our exponential, while the answer in our exponential will be the number 8 in here in our logarithm. So let's have some few examples in here. So let's try this first one in here. It says if y equals 10 to the x, then which of the following is true? In this case, what we're going to do is to write this y equals 10 to the x in the form 10 to the x equals y. In this case, that is of the form a to the b equals c as our exponential, which means that a is 10, b is x, and c is y. Now, let's convert this into our logarithm. In this case, this will now be equivalent to the following. Logarithm, the base number letter a in here will be the base number a in here, and this b and c will reverse each other. Then that means c will be with a and b will be the answer. Therefore, in this case, this can now be written as follows. Logarithm, my a is 10, So that's base 10. My c is y, so I'll put this y with the base 10, and my answer will now be the b exponent in this case, which is x. In most cases, when your logarithm is base 10, that can also be written as simply logarithm of y is equal to x. Because any logarithm without any base is automatic base 10. Going to our second example in here, it says logarithm base 5 of x is equal to 3. In this case, we should write this in the form log base a of c is equal to b, coming from our graphic organizer. Going back, then in this case, a is equal to 5, b is equal to 3, and c is equal to x. Now, writing this down in terms of its exponential conversion, then this can now be written as a to the b is equal to c. In that case, that can now be written as 5 to the 3 power is equal to my c. Now, in order to get my c, what is 5 to the third power using my calculator? So I'll put in here 5. Exponent is always this caret up, and then put it cube or 5 to the third power. Press enter, then the answer is 125. Let's go to our third example. It says log base 64 of x equals negative 3 halves. So again, let's write this logarithm in the form logarithm base a of c is equal to b. In this case, my a is equal to 64, my b is equal to negative 3 halves, and my c is equal to x. Now, converting this into my exponential, then that will be of the form a to the b is equal to c. In that case, I have my a, which is 64. Exponent is b, which is negative 3 halves, is equal to my c, which is my x. So in order to solve for x in here, I'll put this in my calculator. So in this calculator, I'll put my 64. Exponent is this caret up. So it says negative 3 halves. In order to have a, so I'll put a negative sign first. In order to have a fraction, I'll put alpha, y equals enter for my fraction, and I'll put 3 over 2. And then I'll press enter on that one to get my answer, which is 0.00953125. But since my choices are in fraction, what I will do is to press math and then to press 1 to change this number into a fraction. In that case, that will be 1 all over 512. Again, for our fraction, that will be alpha, y equals enter. And for our exponent, that will be the caret up function or button. Now, what if my question looks like this? It says, what is the simplified form of log base 3 of 3? In this case, I will just use my TI-84 calculator in this case. And again, for our calculator function, that should be math. So let me put it in here. That should be math. Sorry. Let's go here. That will be math. Then after math, I'll go to up and see where the log base is. It's at letter A. So I'll click on my log base and press enter. And I'll put in 3 on the base, press right, and then inside a number 3 again. And then I'll press enter for that case. And the answer is 1 in that case. Once again, in this case, I simply use my TI-84 calculator, press math, press up several times until you reach a log base, that's letter A, and then type in log base 3 of 3, and you will get an answer 1. So once again, let's go back to our summary, our graphic organizer for exponentials and logarithms. It also says in here some few examples. 3 to the negative 2 power is 1/9. Can be written as log base 3 of 1/9 is equal to, definitely, that's a negative 2. And for the last one, 7 to the 0 power is equal to 1. That means logarithm base 7 of 1 is equal to 0. Now, please do take time to answer this similar question as we have answered a while ago. Once again, we have done exponential and logarithms. Let me know if you have questions regarding this topic. Tell me, QUAN-do, you QUAN-do math.